Hi, I'm Cheryl Leach. In this problem, we're going to find the indefinite integral, and then we're going to use differentiation to check our answer. Well, let's take a look at the problem that was given. I have the integral of the cubed root of 4x plus 3 dx. Well, the first thing I think I'm going to do with this is to change my notation from radical notation to a fractional exponent. So I can rewrite this as the integral of 4x plus 3 to the 1/3 power dx. Now my integrand is complicated enough that I can't use just basic integration rules to evaluate. So I'm going to think in terms of a u substitution. And when I do that, typically you let u be the inside of your composition function. So let's go ahead and let u equal 4x plus 3. Now if I substitute that in at this point, I can think of this as u to the 1/3 power. That is an expression that I can use a basic integration rule for, but I have a problem. If this is u to the 1/3 and this is a dx, my variables don't match up. If you're integrating with respect to x, your variables must be in terms of x. If you have u's, your differential must be du. So how do I fix this problem? Well, let's go ahead and take a look at what du dx is. Du dx is 4, which means that du is going to be 4 dx. Now this gives me a link between du and dx, but it's not quite right. I would like to have a 4 dx here so that I can replace it with a du. I can fix this problem by multiplying by 1. The form that 1 will take is 1/4 times 4. So I'm going to multiply by 1/4. I'm going to have a 4x plus 3 to the 1/3 power, and then I'm going to multiply by 4, and I still have my dx. So multiplying by 1/4 and 4 is the same thing as multiplying by 1, so nothing has changed. Well, what does this allow me to do? I now have a 1/4, and here's my u to the 1/3, and here is my du. And now it's written in a form that I can integrate. So I'm going to pull out the 1/4 and use my power rule. I'll add 1 to the exponent, that's the 4/3 power, divide by the same number, and then I have my constant of integration. With a little simplification here, I'm going to invert and multiply, so I have 3/16 u to the 4/3 plus c. Now the whole purpose of the u's was to help me to integrate. Integration's over. So now that that's true, I can substitute my x's back into the problem. And I have 3/16 times the quantity 4x plus 3 to the 4/3 power plus my constant. All right, this problem was a little complicated, so let's check our solution by differentiating. I would like to take the derivative of my result. So that's the derivative of 3/16 times the quantity 4x plus 3 to the 4/3 plus a constant. I'm taking the derivative of two pieces added, so let's concentrate on this first term. It's a constant multiple of 3/16 that can be pulled out, and now differentiating 4x plus 3 to the 4/3 power, I use my power rule. I multiply by 4/3, copy over the 4x plus 3, subtract 1 from the exponent, and then by the chain rule multiply by the derivative of the inside piece, which is going to be a 4. Don't forget to differentiate that constant, but that's easy, it's just 0. So now I notice in the numerator I have a 4 times 4, and in the denominator I have a 16. They just cancel. The 3 in the numerator cancels with the 3 in the denominator, and what am I left with? 4x plus 3 to the 1/3 power. And if I take a look at my original integrand, one's written with fractional notations, the other one in radical notation, but it's exactly the same thing. So I was correct. I hope this helps. Thanks.